Okay, ladies and gentlemen, welcome back to Resh's 1800 course, and we're going to talk about Chapter 7.1 continuation and 7.2 and hopefully 7.3, talking about trig identities. Now, the ones that we covered in class and we covered in the last video were the Pythagorean identities and every version of them, so which is sine squared theta plus cosine squared theta equals 1. The other one was 1 plus tangent squared theta equals secant theta, that is squared. And this guy, 1 plus cotangent squared theta is cosecant squared theta. Okay, those are the three versions we've dealt with them in. Okay, now I'm going to do one example for you, and I'm going to drop some very helpful hints that make this easier. All right, so secant of theta, and I want to show that this thing over tangent of theta, I want to show that this thing's equal to sine of theta. Now this is not an equation. I repeat, this is not an equation. So I need to do some manipulation, go down a rabbit hole with this, and hopefully it pops up to sine. Alright, so we know secant is 1 over cosine of theta. Now what am I looking for here when I'm doing this? I see that the left side's already one big blob, and I have more to work with on my left side. But my right side is just sine. So I know I need to get everything in terms of sine. That would probably be my best bet, and hopefully a lot of magic happens. Alright, so let's find the CD here. And look at my numerator. This is cosine over 1. Let's change a little bit of color here to see, so that I can show you guys what I'm doing. I'm going to multiply by cosine of theta over cosine of theta. And by doing that, what ends up happening is I get 1 minus cosine squared theta all over cosine of theta. Life is wonderful. Don't forget I have this fraction over here that I still need to deal with. Now I multiply by the reciprocal. This is equal to this, which is equal to 1 minus cosine squared theta over cosine of theta times its reciprocal cosine of theta over sine of theta. Alright, so I just flip my denominator. You'll notice that these guys factor out, which leaves you, and I'm going to put an arrow here, 1 minus cosine squared theta over sine of theta. Okay, now where do we go from here? Because once again, let me move this out the way. How do I get sine of theta? Well, check this out. This should be ringing bells in your brain. Why so? Observe this guy. This guy says that sine squared theta plus cosine squared theta is 1. So if all you see is a cosine squared theta, this tells me that cosine squared theta, if I were to manipulate the Pythagorean identity, and I were to subtract sine squared theta to the other side, excuse me, that cosine squared theta is that. So through substitution, all I'm going to do is just plug it in for cosine squared theta. So we end up getting inside this little blob, this is 1 minus sine squared theta. Okay, 1 minus sine squared theta, and that's my numerator. Here's my denominator, sine of theta. Okay, and if you, after you do a little bit of algebra here, don't freak yourselves out. Okay, and this is all over sine of theta. Good news, the math gods have smiled, things cancel out, and this gives us this over this. Well, sine squared theta over sine of theta. Wasn't sine squared theta just two sines multiplied together? One of those sines factors out, and it gives me a pure sine, which is what we're trying to show. Bingo, we are done. Okay, so literally that's really all it is. Okay, so this is where I drop Resh's helpful hints for doing identities. Okay, Resh's helpful hints for doing identities. Okay, number one, helpful hint number one, helpful hint. Okay, when in doubt, change everything into sine and cosine. Okay, look for places to use the Pythagorean identities in some shape, form, or fashion. And another big one is basic algebra. Okay, algebra. Look for factoring. Okay, and then watch out, and this is my look for factoring, so like difference of squares and other things like that. And watch out for the big thing is watch out for cancellation errors. I see people all the time trying to divide, for example, sine squared theta over sine of theta, and they just tell me that these two go away and that gives you 1. Okay, no, note this guy up top is sine of theta squared. It's two of them. And this guy is just one of them. It's kind of like saying y squared over y. You're going to have a y left up top. So for this guy, you're going to have a sine of theta left. Okay, so that's kind of the connections we wanted to bring. Don't worry, you need to do tons and tons and tons of examples. Let's do one more. This one should be fun, okay? Because I haven't done this one yet, so it should be quite interesting. Okay? Show, and this is directly out your textbook, I want to show that 1 minus tangent of theta over secant of theta equals, notice the big equal sign, 1 minus 2 sine of theta cosine of theta. Now note, on the right side here, how many things are here? 1, 2. On the left side, how many things? It's one giant fraction. So I need to find some magnificent way of simplifying this guy down. Well, I need to break this into two things. Now, how the heck am I going to do this? Oops, I made a copy error. This is all squared. Sorry. How the heck am I going to do this? Well, let's start doing stuff, okay? Let's see where it goes. Now, remember, we're going to work one side until we get stuck, and then after we do that, we'll work the other side, and hopefully they'll meet somewhere in the middle. So, 1 minus tangent theta squared. I think we know how to distribute this. This is 1 minus tangent. Now I'm going to do this very slow so you can catch what I'm doing here. I'm just writing it twice. Then I'm going to distribute. And after I distribute and simplify, I should end up with this. Okay, how did I get that? 1 minus tangent gives me 2 2 minus tangents, and then I finally get a positive tangent squared. Just distribution all over secant of theta. Alrighty, any luck yet? Well, remember helpful tip number 1. Change it all into sines and cosines. 1 minus 2. This might be a disaster. Let's see here. What's the easiest way I can, maybe that's just the way I'm going to have to do it. 1 minus 2 sine of theta over cosine of theta plus sine squared theta over cosine squared theta. I just want to let you know that there's a shorter way of doing this problem if you're really paying attention to details. Okay? Now, if you look at these fractions I've created, you see this denominator is divided by cosine, isn't it? Okay? So I can add all these fractions up top together, or I can do some nifty algebra. Okay, nifty algebra. But I'm just going to add all these fractions up top together. So once again, watch the birdie. 1 is just cosine squared theta over cosine squared theta. Minus, and maybe we should do this problem again just so you see where it's coming from. 2 sine of theta over cosine of theta. Well, I need another cosine in there, so I probably should multiply in by 1, and I need to give this guy another cosine of theta over cosine of theta. So by doing that, I'll have a CD, and then plus a sine squared theta over cosine squared theta, which is your tangent. All right, and don't forget this is all over 1 over cosine yet. So if you guys are thinking in your head, why haven't I multiplied a reciprocal yet? You have really good feelings. Okay, so this ends up giving me cosine squared theta minus 2 sine of theta cosine of theta plus sine of squared theta all over, yes, that's right, ladies and gentlemen, all over cosine squared theta. And this is, alright, so this is where Resh gets a little lazy. See this? Multiply by the reciprocal, we end up getting cosine squared theta, because I'm getting sick of writing the second denominator. Right? And I'm running out of space. Cosine squared theta times, so multiply by reciprocal, that's just cosine of theta over 1. These cosines are going to drop. Remember, this is a cosine squared. So this 2 is going to go away, and it's going to leave me cosine squared theta minus 2 sine theta cosine of theta plus sine squared theta. And one of those cosines will factor out, leaving you a cosine of theta. All right. Yay. Alright, did anybody see anything that's wonderful? Things should be jumping out at you at this point. You should be doing backflips in your brain because something wonderful has happened, I think. or Resh is screwed up, one or the other. Maybe one or the other, I don't know. Let's see here. Alright, so let's see here, what do we get? We get, my gut instincts tell me I forgot to divide this by cosine of theta. And you who's it, and you'll see why in a second. Alright, think to yourself, what is cosine squared theta plus sine squared theta? This is 1, correct? Minus 2 sine of theta cosine of theta. Oh, things are looking very familiar. And this is why this is a big issue. Check this out. So this is something that actually happened. I actually pulled this off one of your homework assignments in the textbook. It's a typo, right? Why so? Because when you manipulate this, you see how you get what's over here? But it's divided by cosine. For this to be true, they would have needed to have divided this by cosine of theta. So when you do this problem, you're going to think, oh my God, I did something wrong. When not really, they just made an error. Okay, ladies and gentlemen. So go with your instincts and go with your guts. But if you ever have any questions, feel free to email me, feel free to text me, and I'll love to clarify whatever issues you may have. Okay? So, long story short, if you have any questions, email me. But this is basically the whole idea of trig functions, trig identities revealed. So this is 7.1. We finished up. The next video we'll talk about 7.2, which is the sum and difference formulas and how that all ties in to your personal life. All right, so with all that being said, remember, in order to do something you've never done, you are going to have to possibly be prepared to do something you've never done. Okay, so in the end of the day, if you want to go somewhere you've never been, you got to do something you've never done. All right, guys.